All right, Freebody diagram, Lesson B. So, as you can imagine, sometimes the net force doesn't work out so that it's always left or right or always up and down. You might end up with this, and this is weird because you can't add an 80 to the 200. It doesn't work. One's this way and the other's that way. That's not the way it works. But here's how it does work. What you would do, so if you boiled it down to a horizontal force and a vertical force, I would draw them, let's see. It doesn't really matter. Draw one. Let's do the horizontal one first. So it's about that long. And then draw the vertical. So from the tip of one, so you draw from the tail to the tip of that, they call that a vector. We draw the other one. So this is this one, and this is this one. So we draw it like that. And that creates a right triangle. And that, my friends, is what we want. In fact, I'm going to make it a different color just to highlight the fact that that's what we want. It is now going to be green. So this is the thing that we want. And I could have you find that angle too, as a matter of fact, but I will do that in the extension. But what I really need is how long is that arrow? Well, that's okay. Don't panic. This is just the Pythagorean Theorem, isn't it? Where this is 200 and this is 80. And we've done this before. You could go back and look, but the Pythagorean Theorem says that that hypotenuse is equal to 200 squared plus 80 squared. And then take the square root. So 200 squared plus 80 squared, and then take the square root. That's 215.4. So we would say the net force has a magnitude. We would put these two lines on either side, an absolute value, of 215.4. Now, what about the direction? All I'm asking you to do right now, instead of finding this angle, is to give me which one of these directions it's closest to. You might even say, like in this case, if you wanted to, you could say B. I would agree with this. So B is up and to the right. If you wanted to say BC, so it's kind of saying that it's in between B and C, that's fine too. So you would give me a direction. We'll say it is off this way. You can even draw roughly where it is if you want. So it's off a little bit up and mostly to the right. Or you could say it's in direction B or even BC. Any of those would be a good indicator for the direction. In the extension, I'll show you how to find this, although you already know it because it's just the inverse tangent of these two, right? So, let us try another example down here. So here we have these two. So I've got, it doesn't really matter which one we do first, but I'll do this one over and then this one down. 10, 18, you try to make them roughly to scale, so that's about twice, that's fine. And then so what do we want? We want this, the hypotenuse. So if this is 10 and this is 18, then this, the hypotenuse, is going to be the square root of 18 squared plus 10 squared. 18 squared. Here, I'll do it on this calculator just to remind you how to do it. So I would do 18 squared plus 10 squared. Get an answer, and then take the square root. So that's the button underneath there. 20.6. And the answer would be, what you would write is the magnitude of the net force is 20.6 newtons. And for the direction, we'll say F, direction F. Or if you want to draw the arrow, it's down that way. That's fine. All right. So what about this one? Well, we got a little work to do here. You see, in order for this all to work, I needed one force in the up and down and one force in the left and right. So I got the one force up and down. I got to do something about these two. So first, watch this fancy notation. The net force in the x, because you know how when you do a thing, it's x is this axis and y is the up and down one. So the net force in the x is going to be the positive one, F3, minus this one, F2. And so that net force in the x is 500 minus 300. So the net force in the x is 200. Now, what we're going to have to do is redraw this a little bit. So I have a diagram where I have 800 up. That just comes from here. There was nothing to combine with it. So F1 is equal to 800. Horizontally, I have a positive 200. And so really, you could even do this. This is your right, but the direction isn't really correct there. So I like doing it like this. I like doing one of them. So we'll say, we'll start with the 800. It goes up, and then we go to the right with the 200, and this is the direction that we want. So we could do it this way and get the right length, but to get the direction, I like drawing them, do one, and then do the other one off of the tip of that. So we're going to have 800 and 200, and we're going to use Pythagorean Theorem. So the magnitude of the net force is the hypotenuse, so it's going to be the square root of 800 squared plus, getting down there, sorry, 200 squared. And when that's all said and done, 800 squared plus 200 squared, get an answer, take the square root, 824.6, I'm just going to call it 825. And directionally, it's going to be up and to the right. So you might say B would be fine. All right, so we're going to need a little bit of space to do this one. So feel free, by the way, when you're doing these, to get yourself a little extra space. So this one looks like this. All right. So we have to resolve the horizontal, the x, and the vertical. So we'll do the horizontal first. The net force in the x is going to be F3 minus F4, which means the net force in the x is going to be 110 minus 80. And it's going to be 30, positive. So keep that in mind. It's 30 to the right. Whoops. There you go, 30 to the right. Now, in the y, the up and down, I have F1 minus F2. F1 is 70 newtons minus 128. I don't trust myself this late at night, so 70 minus 128, whoops, see, 128, it's negative 58. So in the y, I have a net force of negative 58 newtons. I think at this time is a good time to redraw, that would be down, right? To redraw a free body diagram. So we'll just use a dot. My horizontal is right, 30. You can even, if you have graph paper, you can kind of do like this. You can go 10, 20, you can call each of these blocks 10, that's about 30 right there. Your y is negative 58. So 10, 20, 30, 40, 50, and almost 60, so down to here. Except when I draw them, really you don't even need the negative at this point. What I would have you do to get the direction right is I would draw, say, the 30 first, from here to here, and then starting there, do the 10, 20, 30, 40, 58. And from where I started initially to where I ended, that's the direction. So it's down and to the right, which kind of makes sense. If you're pulling this way and this way, it's down to the right. So my net force, the magnitude of my net force, is going to be the square root. And it doesn't really matter which one I use. And once again, the negative doesn't make a difference at this point. I've already accounted for it. Even if you use a negative when you square it, it should come out positive. But it's going to be, say, 58 squared plus 30 squared. And then take the square root. So, for example, on this, I have the negative 58 there. If I hit squared, it comes out positive. Whoops, made a mistake there. So I had 58, it was negative, and I squared it. Boom. And then plus 30 squared. Got an answer, and then hit square root. So that means the magnitude of the net force, the size of it, is 65.3 newtons. And its direction is down and to the right. So if I was using one of these little descriptors, I would say D. All right? There we go.